In this module, we're talking about the mole, which was introduced to you earlier, molar mass, and various manipulations that we can use with the mole. All right, so remember, if you will, that 1 mole of anything is equal to 6.022 times 10 to the 23rd of that thing. 6.022 is only 4 sig figs. The one over here is exact. The mass, how much 1 mole of something weighs, is called its molar mass, and typically we deal with elements and compounds. So the mass of 1 mole of an element is its molar mass. Now this number, this is called Avogadro's number, 6.022 times 10 to the 23rd. And where it comes from is the definition of a mole. It's defined as, Avogadro's number is defined as the number of atoms of carbon 12 in exactly 12 grams of pure carbon 12. So if we had exactly 12 grams of this one isotope and we could count how many atoms there were, it would be Avogadro's number. So obviously there's a lot more than 4 sig figs to it, but this is all we need to know. Make sure you memorize Avogadro's number to 4 sig figs. Now we can also, this definition ends up meaning that we can convert between AMUs, which we saw in the previous module, in grams. So 1 gram is just 6.022 times 10 to the 23rd AMUs. And 4 sig figs here, exact with the 1. So when we look at the periodic table and we see the average atomic mass for the elements there, that's numerically the same as the molar mass of that element. So for example, the average atomic mass of carbon is about 12.011 AMUs. Depending upon which periodic table you look at, you'll see different sig figs. And so now we know, we get another piece of information from the periodic table. We just look up there and we see that the molar mass of carbon is 12.011 grams per mole. In other words, if we had 1 mole of carbon, we would have 12.011 grams, or vice versa. If we weighed out 12.011 grams of carbon, which is a mixture of its isotopes, we would have 1 mole of carbon. The 1 here is exact, the 12.011 is not. Notice this looks a lot like, because it is, a conversion factor. We can convert between moles of things and grams of things using molar mass. So now that we know that we can look at the periodic table and find the molar mass of an element, if we need, and we oftentimes do, the molar mass of a compound, all we have to do is add up the molar masses of its constituent elements. So for example, hopefully this compound looks familiar to you from lab. Cobalt 2 nitrate hexahydrate is its name. And by the way, this bullet, this little dot here, it just means there's 6 water molecules surrounding every one of these. Well, we'll see this a little bit later in this section when we talk about nomenclature. But anyway, to calculate the molar mass of this compound right here, we just add up the molar mass of cobalt, which we find from the periodic table, plus 2 times the molar mass of nitrogen. This 2 applies to everything inside of here. Plus, now look, gotta be careful, there's oxygen in 2 places, here and here. This 6 means there's 6 waters, so there's 6 oxygens here, and 2 times 3 is 6 here. So we add up 12 molar masses of oxygen, and finally 6 times 2 is 12 molar masses of hydrogen. Here it is, cobalt plus 2 times the molar mass of nitrogen, plus 12 times the molar mass of oxygen, plus 12 times the molar mass of hydrogen, and it ends up, when we multiply this out, when we add, we look at places past the decimal, we end up with 3 places past the decimal, and our answer is 291.034 grams per mole. Now you'll get a slightly different number, different sig figs, depending upon which periodic table you use. On our exams, just use the one I give you. So now that we know about the mole, molar mass, in conversion to AMUs, we can convert between moles, grams, numbers of molecules, or formula units, and numbers of atoms. So let's say we have, 3.141 grams of cobalt 2 nitrate hexahydrate. How many atoms of oxygen are there, and how many formula units of cobalt 2 nitrate hexahydrate are there? So first, let's do this one up here. So what we do know, what we've already calculated, is the molar mass of this compound. And what that lets us do is convert from grams to moles. And so if we know how many moles of something we have, we know how many individual things. That's Avogadro's number. So what I'm thinking is we can take this mass right here, use the molar mass of cobalt-2 nitrate hexahydrate that we just calculated, and convert it to moles of this. Once we know how many moles of this we have, we can find out how many formula units. Formula units is just like molecules except for ionic compounds. So how many molecules basically of this we have by using Avogadro's number, 6.022 times 10 to the 23rd. Once we do that, once we know how many formula units of this we have to get how many atoms of oxygen we have in this much of a compound, we just say, okay, we already know that there's 2 times 3 is 6, plus 6 more is 12 atoms of oxygen in every one formula unit of this. So here's how it works out. So first, we find out how many moles of the compound we have by taking the mass and divide by the molar mass. Okay? And this gives us moles of cobalt-2 nitrate hexahydrate. Once we know moles, we use Avogadro's number to find out how many formula units we have. Look how the units cancel out. Moles cancel, we get formula units. By the way, 4 sig figs, more than 4 sig figs here, 4 here, 4 here. 4 sig figs rounds to 6.499 times 10 to the 21st formula units of cobalt-2 nitrate hexahydrate. All right, so that's the first question. Now, to get at the atoms of oxygen, all we do is take how many formula units we have, multiply it by 12 atoms of oxygen per every one formula unit, and that tells us how many atoms of oxygen we have in 3.141 grams of cobalt-2 nitrate hexahydrate.